Hello everyone and welcome to another episode of Investigation. In today's episode of Investigation, we'll go over 2022 AMC 10B number 22 or 12B number 21 as well. Before we get started, I want you to, if you have any questions, even if it's not related to this one, please put them in the comment section below. And if you have any doubts about this question, maybe during the video you still have doubts or you still have questions you don't understand, please put them in the comment section below as well. I will answer them one by one when I see it. So let's get started. It says, let S be a set of circles with coordinate plane on the coordinate plane are tangent to each of the three circles with equations x squared plus y squared equals 4, so like a circle with radius 2 at the origin. X squared plus y squared is equal to 64, a circle with radius 8 at the origin as well. X minus 5, so the center is at 5, 0, and plus y squared equals 3, so the radius is going to be square root of 3. So, of course, this is kind of like a very bad drawing, but I have prepared you one more accurate drawing over here so we can work with that. All right, so it says that, and we want to find the sum of the areas of all circles in S. So there are two cases, right? If we are, well, I guess you could consider a case where the circle is externally tangent to this big circle. Then, well, yeah, it's not possible. Like, it can't be tangent to the inside one because, well, the circle has to be inside the bigger circle for it to start with. So that's not going to be a case that we are going to consider over here. So now we have two cases. Case one would be externally tangent to the small circle, x squared plus y squared equals 4, or I guess the medium circle, if you think about it, or internally tangent with this medium circle. All right, so it is externally tangent to this big circle and internally tangent to this small circle, or externally tangent to the small circle and internally tangent to the big circle. So it looks like this. And we want it to be tangent to the third circle as well. You can think of it as like this circle rolling around this, I guess, ring, kind of donut-shaped thing. Because, well, if you think about it, if it's externally tangent to the small circle and internally tangent to the big circle, then there's only one size, right? So you can rotate this circle. Okay, now there's one circle here. Okay, go, 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 go. Boom, two circles here. Go, 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 go. Symmetrically, 3 circles here, and here 4 circles. All of the circles have the same size, as I have demonstrated. If we just draw a line from this to here, because this origin is also the center of the big circle, it passes through the point of tangency, both points of tangency. This has a side 2, so this have to have a side length of 6. So the radius is equal to 3. So we have 4 circles such that the radius is 3. So it's 4 times pi times 3 squared, or 36 pi. Okay, now let's consider case 2, where it is internally tangent with the small circle, or the medium circle, as you might say. You might think, how is that even possible? Well, it is actually possible. Let me resize this circle over here. It would look something like this. It will be bigger than the case 1 circle over here. So we want, well, again, to be tangent with the third circle. So we have one choice. Again, over here, we have 2 choices. Again, going around the circle, just kind of rotating this. Boom, 3 choices. And then around this way, boom, 4 choices. So, okay, let's just take one choice as an example over here. Just take a look at this one over here. Then we would have, if we just connect from the point of tangency to the point of tangency, it will be collinear, right? Because the circles have the same center. This is a line, and we know that this side length is going to be 8. That is the radius of the big circle. So the radius of the added circle, the circle in S over here, is just going to be a plus 2 divided by 2, or 5. So in case 2, we're going to have 4 of the circles with area pi times 5 squared, or 100 pi. And that is out of the possibilities. You know that is out of the possibility because, well, it can only be either externally tangent or internally tangent to the medium circle. So we have 36 pi plus 100 pi, which just give us 136 pi, or answer choice E. And that will be it for this question. And again, if you have any questions related to this one or not, please put them in the comment section below so I can get to them and I will answer them one by one. And for now, that will be it for this episode of Investigation. And I'll catch you in the next one. See you there.